Now let's take a look at another synth that works in a slightly different way to create some great sounds, Rapture. It's a synth that still has the basic concepts of oscillators, filters, modulations and effects, but also features a step generator. The way patches or programs are constructed is slightly different too. Let's take a look. A Rapture patch or program is similar to those in Dimension Pro in that it uses elements. In Rapture, a program can consist up to 6 elements. A single element consists of a wavetable oscillator and a chain of effects, filters, modulators, a step generator and LFOs. We can combine all or some of these elements into a single sound or assign each element to a different MIDI channel. Let's have a quick overview of the interface. At the top, we have the program selection controls as well as various display control icons. Beneath that, the main interface consists of 7 pages. 6 of them are identical, one for each element, plus a global control page. We'll take a closer look at the global page later. For now, we'll concentrate on an element page. At the very top, toward the left, is the oscillator section. Right of that, the filter and drive section. Beneath those is the modulation area, split into 2 horizontally. At the top is the envelope generator and LFO modulators, and beneath that is the step generator. Unlike some of the synths we've looked at, where envelope generators and LFOs are assigned to parameters, Rapture has 7 pages for each element. Each page has an envelope generator and step generator with identical controls, but they are already pre-assigned to various functions. There's one for pitch, one each for both filters cutoff and both resonance parameters, another pan, and another one for the amplifier controlling output. We'll look at all of those later. Beneath that is the master and effects section. Here we find 3 individual EQs and an effects insert area where there are a multitude of effects to use, as well as another LFO for modulation. At the very bottom is a mixer for control over each element, and to the right corner are the master output controls. So let's take a closer look at each of these sections and see how they all work together to create the sounds we hear. First, the program selector. This displays the name of the currently loaded program. To the left is a drop-down that displays all the recently used programs. Click on the name area to show the browser for access to programs and folders. Right of the name field are a pair of arrows to step through the programs one at a time. The first icon in the icon panel is for program handling, where we can load and save programs using Windows Explorer. Next comes the Options window for setting various options, including Monophonic Mode that I mentioned earlier. In this mode, each element is assigned to MIDI channels 1 to 6 respectively. They can then be played back as individual elements using those channels from your keyboard controller. Just like Zeta, Rapture has a modulation matrix. Click on this icon to show or hide it. There's also an XY pad, shown or hidden using this icon. Now let's take a closer look at an element. Each element can be loaded or saved as a separate entity. Right-click on the Element button to reveal a menu. Here they can also be saved, unloaded, reset, copied and pasted, as well as have their routing changed. Each element has one oscillator. We can still use more than one at a time though by chaining one element to the next. Select this option here and the output of this element will go to the input of the next, allowing common controls and effects to be applied on that element's page. All of them except the last have this option. All except the first also have the option to ring modulate the previous elements using the current element as the modulator. We looked at ring modulation in a little more detail earlier. The basic sound is created by a wavetable or sample. These are loaded into the oscillator by clicking on the wave display area. Here we can see the current loaded wave file's name, as well as a visual representation of the wave. Once loaded, we can edit several parameters. The low-high key adjusts what MIDI note numbers it responds to. For example, if we change the low setting to 55, this element will not sound if MIDI notes 54 or lower are played, but will if 55 or above are played. Change by either click-dragging up or down over the display, or double-click for direct note entry. Low-high velocity does the same thing, but corresponds to note velocity. Using these 2 parameters, we can change a sound based on either its pitch or how hard a note is played. Bend up-down sets the range of the pitch wheel in semitone steps. Sus and Stost controls whether the element responds to incoming sustain or sustenue data or not. Transpose and Tune change the pitch in steps of semitones or cents respectively. Key track, we've seen elsewhere, that changes the pitch variation for each key in cents. 100 is the standard, giving a semitone per note as we expect in the Western scale. A setting of 0 gives no variation at all regardless of incoming MIDI pitch. That's useful for percussive sounds. Other settings other than 100 might be useful for creating unique scales. Phase adjusts the initial starting phase for each note on message. Quality sets rendering quality. High should be used for sounds with large sweeps to avoid audible aliasing. Multi is similar to the multi-mode we've seen on other synths, effectively turning the one oscillator into multiple oscillators. Cycle through choices of 3, 5, 7 or 9. Detune controls the detuning in this mode. Ring modulation turns the oscillator into 2, with one wave modulating the other to create the classic metallic sound. In this mode, Detune controls the detune level between the two. Porter forces pitch glide when in legato mode. That is set using the polyphony field, which specifies the number of voices that can be played back at the same time. Legato mode is set when polyphony is set to 0. Polyphony set to 1 is monophonic mode. Layers sets which layer of a multi-layered sample is played. That's unavailable if a single layered sample is loaded. Once the signal leaves the oscillator, it's routed to the Digital Signal Processing or DSP section. Here, there are 2 filters with a multitude of types to choose from, several drive types and 8 other DSP transformations. At any one time, both filters and up to 3 of the DSP effects can be used. The order of filters and processors can be changed by either left or right clicking in the signal chain display at the top, or clicking on the arrow to reveal a drop-down to directly select an option from the list. The actual filters and DSP effects used are chosen from the next row. The first drop-down reveals a list of filters. These consist of 5 low and high pass filters with different roll-off slopes, one of which is a variable state filter. Except for LP1 and HP1, which are one-pole filters, they all feature resonance. There are also 3 bandpass and band reject filters, including a variable state version. In addition to all of those, there is an all-pass, peak, comb and pink noise filters. We looked at how low, high, band reject and other bandpass filter types work elsewhere. An all-pass filter creates a very slight delay, thereby shifting the phase slightly. It creates a very subtle effect, most useful for adjusting phase issues between 2 different elements. A peak filter boosts frequencies around the cutoff, and the peak width is controlled with a resonance control. That's similar to the resonant boost filters we saw in Zeta. A comb filter is similar to a notch or band reject filter, except there are multiple notches that are used to colour the sound. These notches, when viewed as a graphic WAV file, resemble a comb, hence the name. A pink filter uses multiple low-pass filters and has the effect of darkening the tone slightly. The variable state versions of filters cut and boost around the cutoff frequency, providing a different colour to the resonance. The next 3 drop-downs are for various DSP effects. There are 5 drive types, several distortions and lo-fi effects, any of which can be loaded into the 3 slots, so it's possible to run any combination, including 3 of the same type if you wish. The cutoff frequencies and resonance are adjusted with those controls. If a chosen filter doesn't have resonance, that control is dulled. The amount of each of the other processor's effect added to the sound are controlled with a rotary underneath the processor selection area. Remember, this actual signal routing order is controlled from the drop-down above. Now let's take a look at the modulation area.